All right, this is use the given categorical data to construct the relative frequency distribution. Natural bursts randomly selected from 4 hospitals in the highly populated region occurred on the days of the week in order from Monday through Sunday with the frequencies. Does it appear that such bursts occurs on the days of the week with equal frequency? All right, now just looking at this data, 54, um, Monday has a frequency of 54. Um, Tuesday has a frequency of 65. We have 71. These are not equal frequencies, right? So um, let's go ahead and fill this relative distribution out. This is just totally a calculator activity, right? All right, so let's get the relative frequency for Monday. So what's the frequency for Monday? That would be here. This is the data. Um, you can copy it to the clipboard right here, right? Here. That didn't work very well. Yeah. Okay. So Monday has a frequency and then we have a relative frequency, right? So we do want to extend the table out to show the relative frequencies. So we've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so on Monday, the frequency was, it's at 54, and then we had 65, 71, 56, 57, 43, 54, all right? And the relative frequencies, so we really need the sum if we're going to do the relative frequencies, all right? So let's add this up first. Or did they already give that to us? No, they didn't. So we really need to know how many total bursts all together, right? For all days a week. So did anybody do that one yet? Shantae, you have 400. Does everybody agree with that? Was it 400?
Yeah.
Okay, great. I'm going to put that in there. The sum is 400. Awesome. Okay, now we just need the relative frequency. So, all right, what's the relative frequency for Monday? Excellent. And I love the fact that you already turned it into a decimal, right? Because this is a percent. So this is 13.5%. Great. All right, let's do that for Tuesday as well. And the rest, 65 divided by 400. All right, so we have 16.25%. Okay, and the next one, what's 71? 17.75. And then 56. 14%, right? Shantae, you're on a roll there. Awesome. Anybody else? What's the next one? Let me know when, type in the chat if you're explaining and I don't identify you because then my mic is, then I can't hear for some reason. I want to make sure I can hear you all. 10.75 and let's see, you got 15%, Mohammed. How'd you get 15%? Oh, 15 point. How'd you get that one, Mohammed? And I can't hear, so in case you're talking, but. So Mohammed, it looks like you have 15.75%, right? But I'm not sure 54 over 400. I got something different. Anybody else get something different? What percent is Sunday?
For 54, I get the same thing as we get for Monday 54, 13.5.
Yes, that's what I got too. Yeah. Okay, great. Yeah, wow. Uh, that's pretty cool, Shante. I didn't even look at that. I just typed it on my calculator, and yeah, you could just bring that one down to from Monday. Very good. Yeah. Oh, I got you, Mohammed. Right, you're doing your own data. That's fine. I'm okay with that. If you guys want to do that, hey, anytime you want to share your screen and you want to do your data, I'm happy to do it. Okay, just holler. Okay. All right. Let's see. So we've got all the percentages, right? And I'm gonna move to the next problem. I'm gonna go to number 12. That looks the same. Uh, all right. So they're asking what percentage of the customers responded that the merchandise was the reason they shopped at the store. We're going to round to the nearest whole percent. So we have to do the percentage of, here we go, the percentage of customers who responded that the merchandise was the reason they shopped at the store. All right. So we need to know, so to find the percentage of customers, we need to take the number, right? That, or the frequency that chose the merchandise over the total number, right? So we're looking at total number of frequencies, okay? So the frequency of the merchandise over the total frequencies. Okay, so merchandise we know is 30, but what's the total? Did anybody add those up? 20 plus 30 plus 10 plus 10. All right, so what's the total there?
70.
Right. All right, and then 30 to 70, what's the percentage there?
And we need to round, it'll be 43%.
43%, great. Because I got this 0.4286,
Mm-hmm.
and that's equal to 42.86. So we first have to turn it into a percentage, and then we round. I don't round ahead of time because I really need to know. It says round to the nearest whole percent, and I can't do that until I've actually converted it to a percent. Okay, so there you go, 43%. All right, so we have in a statistics course 26 A's, 60 B's, 50 C's, 40 D's, and 24 F's. Select the pie graph that correctly represents the scores. All right, so y'all choose A, B, C, or D. Okay. And so we're definitely going to need a total here, right? 26 plus 60, because we need to find out what percentage of the class are A's, right? We have to convert this to get this into a pie chart. We really need our percentages, right? So A is 26 over whatever the total is, right? So we get 60. So that's,
200.
is it 200? Okay,
Yes,
200.
ma'am.
Great. Okay, which is 13%. And B is, all right, let's see, what's B? 60 over 200? That's 3/10.
30%.
Great. Okay. So now I'm looking at this chart. This is quarters. This is 25% region. So B would be something like this right here. That would be B. All right. So looking at the options here, A or C would have 30% in it. Let's see. And D is too much. That's like 70% or 60% there. So we know that it's either A or C now. So we've limited our choices. And then we need to come up with, and then A is 13%. And so which, let's see. So A and B are both the same for A and C. So now we need C. And that's what? 50 over 200? That's
Yeah. 25.
25%. Okay. So here's C, right? And so let's see. Oh, okay. So now we have that first graph, right? Where the first three are done and the rest are wrong. Yeah. Okay, let's see. Let's move on to a different kind of question. So that's number 15. Let's just skip around a little bit. 50 teenagers were surveyed about their favorite drink. The following shows the survey. What's the mode? Okay, so we have Coke, 28 preferred Coke, 12 preferred Pepsi, 10 preferred Sprite. So the mode would be Coke because of the frequencies, okay? Just do not choose the number for mode, okay? Some students make the mistake of choosing the number, the frequency, but that wouldn't be the mode. You know, I want to say 28 is the mode because 28 is just how many times that occurred, okay? So Coke would be the mode of this data. I'm just going like every third problem here. 100 men were asked what their favorite online bookstore was. 22 said Powell's, 30 said Barnes and Noble, 38 said Amazon. What is the mode of the survey here?
B.
Amazon. Great. Right, because it had the highest frequency. Great. All right, 21. Now we go to, let's go over to 24. Which of the following descriptive statistics would best measure the average lifespan in years of a computer?
The mean.
The mean is the best for average. It's the best measure of central tendency for average, right? As long as with there's no outliers, okay? That skews the mean, okay? Because outliers can skew that number, skew the mean, all right? So the median is best for when? For
If
data,
there is.
yeah, with outliers, yeah, because it is not affected. It's because it's not affected by extreme values. Okay. All right. So so the average lifespan of a computer, that would be the mean, and then which is the better Which of the following descriptive statistics would best measure the consistency or reliability of the computers? The mode, the mean, the standard deviation, or none? Okay. All right. The standard deviation basically measures how far from the mean all the data is. Okay. It's the spread. It measures how far from the mean everything is. So um, how far data is from the mean. It's kind of like has to do with the z-scores too, right? So let's see. Okay, now here, this is just using our calculator for the one variable stats program. Shall we all try this one? All right, calculator activity here.
Sure.
Okay, we have the top 10 annual salaries in millions of dollars of TV personalities. Find the range, variance, standard deviation. All right, so let's go ahead and practice here with our calculator. So we're going to press stat, enter. And then I've got some data here, so I'm clearing my list here. Arrow up and then clear, enter. All right, arrow up, clear, enter. I'm okay if you're using your own data, that's fine. I'll do mine and you do yours. And although somebody's got to check my work
I got 28.2.
for the range. Okay, now the range has something to do with this. All right, this is number 25. So the range is the max minus the min, right?
Mm-hmm.
And I'll get right back to you, Shantae. Just I want to check my measurements and just make sure I did that right. Okay. So I have 11 here. So everybody had 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 10. So I did something wrong. Oh, I have an extra 11. There we go. All right, now I've got my 10 data points here. Okay, and then I'm going to go to stat, calc, enter. Make sure you choose the right list. My data is in L1. That's second one if it's not there. And I have the mean, the standard deviation, and all this other. All right, I'm going to go down to the 5-number summary. Okay. And so the range will have to do with the minimum and the max. So we have 40 minus 11.8. Okay. What'd you get, Shantae?
I got 28.2.
Yeah, great. All right, so the range is 28.2. And the variance. Okay, so we need that calculator program. The variance, how do we get the variance?
The standard deviation squared.
Yeah, very good. So our standard deviation is, what is my standard deviation here?
11.33.
11.3.
274998.
Now let's see what it says. Round to 2 decimals. Okay, I'm going to put 11.33. Okay, and we're going to square this. Good.
128.43.
All right, and then I'll square 128.3. Did you get a different decimal, Shante?
Well, I didn't round until after I squared.
All right, so well, you're right, but you may get it wrong when you type it in, um, because it's asking you to round to 2 decimals. So that's a big question. Like, how do you round the standard deviation before squaring it? So they're basing this number on doing the standard deviation by hand and rounding it to 2 decimals, and then
Okay.
getting your all right. So this is variance. Okay, this is variance. Hold on. Let me put this. I'm gonna put that on another line so you're not confused. So variance. We're gonna take this number already rounded to 2 decimals and then square it. Okay. That's S squared. 11.33 squared. And so we get this 128.37. All right, yeah. Just so for this one, you want to round. So if they ask you for the variance before they ask you for the standard deviation, then just take it to this 2 decimal places if that's what they're asking. It says 2 decimals, so round the standard deviation that way as well. And then you should be able to get it right. All right, and now it wants you to get the standard deviation. Now I'm going to put this one 11.33, and there we go. Because they're basically saying take this 128.37 and take the square root of that, but that gives you right back to the standard deviation, right? So if you were going to take the square root of that answer, you should get right back to that 11.33. Okay. So that's not a necessary step for that particular problem. We were on 25, right? So is the standard deviation of the sample a good estimate of the variation of salaries of TV personalities in general? So we really have to read the problem for this question, all right? So here we have the listed below are the top 10 annual salaries in millions of dollars of TV personalities. And we found the variance or the standard deviation of this data. They're asking, is that a good estimate of the variation of salaries of all TV personalities in general?
No,
Right? No. Why is that?
because it didn't do the whole thing. It just did the top 10, the top
Exactly.
10 salaries.
That's a terrible way to do to find out how well they're all doing, right? So When you think of TV personalities, that goes from, TV programs for children all the way up to, the Netflix series, or, it's, um, you really have a large range. You can't just take the top 10 and get an accurate number. So that's a good answer. I'm going to move on to 25, 26, let's do 28. Oh, percentiles. Okay. So percentiles are easy enough if the data is in order. It looks like the data is in order. So this is a good way to use my wonderful notation here. All right, so the percentile of 4.8. All right, and so the percentile of 4.8 is equal to the number that's less than that, the number less than the number of cell phone speeds that are less than 4.8, all over the total, let's see, or all over the total number of data collected. Okay. So does anybody know what the total number is here? Does anybody add up all this, just how many numbers we have?
50.
Yeah, there's 5 rows of is it 10? Yeah, 50. All right, so we have 50 data. And how many are less than 4.8?
34.
4, great, because we got 3 rows plus 4. Yeah. So 34 over 50, which is 68 over 100, if you want to do a little mental math. So 68 percentile. So 68 percentile. All right, so this is a calculator activity. We're going to have to order this first, unless you want to do that by hand. So let's put the data in our list. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just double check to see you have 15 values. And it looks like I mistyped that first one. That's 12. Okay, so in order to find the percentile, we need to sort this. All right. Does anybody remember how to sort the data?
Yeah, press
Sort.
the stat button, sort, and then the list you want.
Right. Stat, and then we go down to sort in ascending order. And then we're going to put our list that we want to sort. Stat. And that's 2. Put in second 1. Enter. And then to view it, to view the list, we're going to press stat and then enter as if you were going to edit the list, right? All right, so to view the list, we put stat enter, and then you see it all in order, which is very cool. And now we're going to look for the value of 42. Okay, so to find the percentile of 42, I see that that's the 10th number. So one less than that is 9 out of a total of, I forget, how many? Did we have 15? 15 numbers? And then we just need to get the percentile of that. So I'm going to press second mode. And 9 divided by 15 is 0.6, which is the 60th percentile. So if you score in your next statistic test, and that's converted to a z-score, which of these z-scores would you prefer? A 0, a -1, a -2, or a +2?
D.
D would be, yeah, 2, because that means 2 standard deviations above the mean. The mean of 108.06 and its standard deviation is 115.45. Let's find the z-score of that score. All right. So the z-score, what's the formula for the z-score? The score?
X minus the mean over the standard deviation.
Standard deviation. Excellent. Right. So here in this problem, the z-score for that one right there, that 108.06. So we take that value, 108.06, that's our x, and we subtract the mean. Oh, no, never mind. That's not it. What's the score that they're asking? The score is 489.67. So 489.67 minus the mean, which they give us is 108.06, and then divide that by 115.45. So what do you get?
I get 3.31.
3.31. Good. See? Good. Let me move to, I'm just going to try to skip a little bit. Let's go to 35. All right, we have a few people that came in a little late. I want to make sure I have your attendance. All right, so I've got Catherine, Kathleen, Andrew, Zara, Divi, Angelica, Precious, and Mohammed. And we have Asmita, Ariel.
Here, I'm here.
Great, thank you. Anybody else?
Me,
Who's me? Oh, Cindy?
Zena,
And, oh, and I see Cindy and Zena. Okay. For those who came in late, I don't know when you came in, but we're doing the review for homework for test 1 that covers chapters 1 through 4. Okay. So the test opens, when does it open? It opens today, right? It's open now. And it is due on Sunday midnight. Okay. I think the test opened actually early yesterday, but it's due on Sunday. All right, let's see. The tallest living man at one time had a height of 241 centimeters, and the shortest living man at that time had a height of 133.7. The heights of men at that time had a mean of 177.96 and a standard deviation of 7.02 centimeters. Which of these two men had a height that was more extreme? Okay. So we're going to look for the z-scores of each man. So the z-scores, right? The shortest living man at the time had a height of 133.7, right? The tallest living man had a height of 241. Okay, so we're going to do the z-scores for each of these men, knowing that our mean is equal to, let's see, what does it say? The mean is 177.96, and the standard deviation is 7.02, right? So we're going to see which of these scores is a little more extreme than the other, okay? So we have x minus x bar, so 177, I'm sorry, 133.7 minus 177.96 all over 7.02. And this one is 241 minus 177.96 over 7.02. All right, so let's get the z-scores for each of them. All right. All right, go ahead and do the tall, or this is the shortest man. Did anybody get the z-score for the shortest man? Okay, thanks for your answer there, Catherine. So you have, is that right? 6.3 for this problem? Because that's a large z-score. That is very extreme. All right, and let's get the shortest the z-score for the shortest man, and then the z-score for the tallest man. And if you would, when you do type it in, let me know whether it is the z-score for the shortest or the z-score for the highest, the tallest. Okay. Oh, wow. Yeah, that's but it's a negative, right, Catherine? And because we are subtracting the larger number from the smaller, we have to always subtract the mean, right? Forgot the negative, great. Yeah, so this is a negative 6.304, that, or 5. That is highly unusual, right? Because what's usual is scores that are z-scores that are between what two numbers? Negative 2.
-2 and 2.
That's what so when you get a z-score that's so far out, like then like a -6, okay, then we're really, this is very rare here. Okay, and the largest one, the tall person, okay, everybody agrees it's a 8.98. Shantae and Catherine. Okay, great. So 241 minus 177.96, enter, divide by 7.02. Yeah, 8.98. Okay. So, all right, which of these men, right? This is the shortest man, this is the shortest man, this is the tallest man, right? Which of these men are more extreme? The tallest man on earth or the shortest man? So, yeah, the tallest man. Very good, because he's because here and this is how we say this is that the shortest man is 6.3 standard deviations below the mean, right? And the tallest man is 8.98 standard deviations above the mean. Okay, and that's really showing you how the one is more extreme than the other. Okay, because when you say it this way, we talking about how far away they are from the mean, so we're not even using the negative anymore. Okay, so that was 35. I'm going to skip over to 38. Use the data in the following table, which lists the drive-through order accuracy at popular fast food chains. Assume that orders are randomly selected from those included in the table. If one order is selected, find the probability of getting an order that is not accurate. So let's copy this table down because we're going to definitely need some totals. All right, so let's make sure we get our totals in there. Does anybody have the totals for all the accurate orders? I get
984.
Great, thanks. I'm glad you did it as well. Okay, let's get the total not accurate orders.
130.
Okay. All right, and then 984 plus 130. is
11 or 10.
okay. And make sure that when you add all your totals in both column, the last column and the last row, hopefully you'll get the same number. Okay, so this is your grand total. All right. So the question is, find the probability of getting an order that is not accurate. Okay, so an order that is not accurate. All right, I'm looking at this number here, right? All right, so how do we write that as a fraction?
130 over 1,000, 114.
4. Good. All right, and then it says round to 3 decimals.
0.117.
And the probability, now is this a different number? Yep, different. Okay, so here, let's see. So this one is find the probability of getting an order from restaurant A or one that is not accurate. Okay, so so for 39, all right. So what are A's? The total orders for restaurant A. What are the total orders? 319 plus 38.
357.
So 357. Okay. And the total orders for accurate. So we need to get that 319,
975.
240. Okay, you got that number? What is that again, Shante?
975.
95? Okay, great. So the probability of getting an order from restaurant A or an accurate order, okay, is equal to, all right, so A is 357 over, we need the grand total. So I guess the grand total would have both accurate and total not accurate orders, right? That's what it is.
1127.
So the total of not accurate is
Oh, not accurate.
152. Yeah, let's get that number. 38 plus 55 plus 39 plus 20.
152.
152.
Okay, awesome. Great. Thanks, Catherine. 152. So what's our grand total?
1127.
Okay, so we're going to add 152 because the total accurate orders was 975. Total non-accurate is 152. Right, so 357. Which is what? 352 over 1127. Okay, great. So the grand total is adding those up. Okay, so this, yeah, here is the grand total. I'll go ahead and write that down. The grand total is 1127. Okay. All right. So the probability of getting an order from A is 357 over the grand total of 1127. Okay. Now the probability of getting an order that's accurate is 975 over the grand total, right? But we had overlap, right?
Mhm.
Yeah, and I didn't copy this whole table because it was time consuming, but the overlap, you always want to see where the orders overlap. Here, I'm going to get another,
319.
and that's right here, right? Because we're talking about accurate orders and restaurant A, and the overlap is at that 319, right? So subtract, let me get out my annotation now. Minus 319 over the total, 1127. Yeah. And now we can put that in our calculator.
$909.
All right. So we're going to add everything in the numerator, subtract that 319, and then divide by 1127. Is that what y'all get? 0.8944?
Mm.
No?
I
352,
may have did it wrong.
319. Yeah. So there you go. And it says to round to 3 decimals, so we get 0.894. Okay. So I just suggest that you do it this way, the last problem, right? You copy the table and you get all your totals, get your grand total, and then start doing the diagramming where you can highlight what they're asking you. In that problem, they were asking you not accurate orders, okay? But when you have an OR problem and you have a vertical and a horizontal, you're going to want to see where they intersect and then circle the intersection because that's what you have to subtract, the overlap. Okay. So that's 0.894. All right. There must be a total wrong in here somewhere. Okay. Let me clear my annotations. Did anybody get a different answer for that? Okay. So what I'll do is to save time, I'm going to go
I
ahead
got
and orders. Go ahead. I'm going to do
I
is,
got 0.909, but I don't know if that's right.
it could be.
I
Yeah.
don't remember how.
Okay. So I'm going to just add up all the accurate orders again and just make sure, because I didn't do all the math on that. And I'll put this on my own calculator. So we do get the 975 here. Oh, that's not a good color, is it? Okay. So this is 9.75. Oh, not 9 point, but 975. Okay, let's go ahead and get that not accurate order again. And we get 152. That looks good. And then the grand total, 1127. That looks good too. Okay. And then we need to find, it says restaurant A, right? So we need to get the total of A. So that's 357. Okay. So the probability of getting an order from restaurant A or an accurate order is equal to 350. Oh, let me go ahead and highlight those columns first. Okay. So here's A. Wish it was a highlighter. Sorry about that. Just give me a second there. I'll just circle it. Okay. So here's A. And then an accurate order is right here. All right. Okay, so restaurant A would be 357 all over, total of 11.7, plus an accurate order, which was 975 over 1127. Looks like we have the right data there. Minus 319. Yeah. Okay, I think I must put in my calculator different. So what'd you all get when you added up the numerator and divide by 1127?
I got 0.8988.
I see what I did wrong. It's 357. Right, 8.8988. Right. And then round that to the nearest 3 decimals, 0.899, right?
Yeah.
Awesome. I had a 352 up there. It was supposed to be 357. Okay. That's 39. I'm going to clear this, my annotations. Oh, I missed that last question. What was that question? Oh, that was 39, right?
Mm-hmm.
So are the events of selecting an order from restaurant A and selecting an accurate order disjoint events? Well, they are not disjoint because the only way two restaurants are two events are disjoint if they have no overlap. They have nothing in common, but they do, right? Getting an accurate order in an order from A, those have some commonalities to it. So they're not disjoint because it is possible to pick an order from A and one that is also accurate. So let's move to 42. Eli has a jar full of marbles. In the jar, there are 15 blue, 11 red. Now, looks like we go to 9:50, so we have 10 minutes, right? So we are really close, right? Because we're on 42. We're close to the end, so I want to make sure I get to your questions, okay? Is this a good one to do, or do you want to, let's see, probability that the second marble
Yes,
is,
we can do that.
yeah, this is a given problem, so that's a good one. Okay. So she selects a marble at random from the jar. She does not replace the marble. She selects a second marble from the jar. What is the probability that the second marble is red, given the first marble was not red? All right, let's write down the facts to the problem. 40. Okay, so this is number 42. We have 15 blue and 11 red, 13 purple marbles, for a total of 39. There is no replacement here. Okay, no replacement. So when she gets that second marble, she's going to have a new total. So what is the probability that the second marble is red given that the first was not red. Okay, now this given part here is the new total. Okay, so that it was not
11/38.
no, that's red. Not red would be 28 over, it would be 28. Okay, that number is there's 28 marbles that are not red, right? Because it's 15 blue plus 13 purple, right? So that's our new total. Okay, so this is equal to something over 28.
11/28.
20, not red. So yeah. So given the, sorry, let me do this over.
No, 30.
It's not the new total. I'm sorry. Just give me a second.
11/38.
So you have 11. All right. So the 11, yeah, because we have 11 red marbles left out of 38 total. Yes, very good. Yeah, we picked of the, it's not like we need that number actually. So, right. It's just that we need to know that we didn't pick a red one. We picked a blue or a purple. So we don't really need that total. Yes, and we have one less total to choose from. So we changed the denominator to from 39 to 38 because of the fact that we picked a marble already, and we have a total of 11 left. .2894. So rounded to 3 decimals is 0.289. Yep. Oh, I didn't do this. So this is the probability, red in the second, given red in the first. Yeah. And then the probability, the second one. Let's go to, we don't have much time, so we got a couple minutes. We're at 43. Does anybody have any preference of where we want to go with this?
No.
This one is Elizabeth brought a box of donuts. This is find the probability selecting a lemon followed by a custard. All right, we want to do this one or a different kind of problem?
Yeah, because I messed up on this on the quiz.
Okay, so this is number 47. So we have 24 donuts in the box, and we have we have 3 are jelly, so 3 jelly and 4 lemon and 17 custard. And you randomly select a donut, eat it, select another donut. So there's no replacement. Find the probability of selecting a lemon-filled donut followed by a oh, now this is not a given because it says followed by a custard donut. Okay, what this implies is the probability of a lemon and then a custard. Okay, this is implying that we use the multiplication rule. All right, so we're going to take the probability of lemon times the probability of getting a custard given you already picked a lemon, because that replacement part is kind of important. Okay, the fact that you ate the first one and didn't replace it. Okay, so you're going to have a new total for the second probability. So what is the probability of getting a lemon donut?
4/24.
Yeah, 4 out of 24. Okay. probability of getting a custard. Okay, so once you've eaten one donut, you have
17 over 23.
how many are custard?
17.
17, right. We didn't eat a custard, so we still have, 17. We just have two, what is it? 3 jelly. You ate a lemon, so you have 3 lemon, and you have 17 custard. So that new total is 23. So the probability of getting a custard donut is 17 over 23. And then we just put this on our calculator. And I would use parentheses for the two fractions. And it says to type an integer or simplified fraction. All right. So I need to press math, enter, enter, and it'll put it in a simplified fraction. So it's 17 over 138. That was number 48, 49, 50, 51. Here's 51. We've got 3 minutes left, and we're almost, kind of already been through this almost. There are 17 exercise bikes in a fitness store showroom. The fitness store owner wishes to select 4 of them to display at this expo. How many ways can a group of 4 be selected out of 17? So the question is, we need to know whether it's a permutation or a combination. Okay, so this is number 51. So is it a permutation or a combination? And then we need
Permutation.
permutation. So we want to select 4 to display. Okay, this is actually a combination because we don't care about the order that we take the 4. And Catherine, you already did or you get the last one, right? Okay. Yeah, it looks like you did that. Okay, so it's a combination of n items taken r at a time. Now n is 17, r is 4 at a time. So this is a combination of 17 items.
2,380.
All right, so I'm going to press 17, math, prob, and I'll catch up to you guys. So number 3, and then I put in my 4, and we get 2380. Yes, Catherine, good. 2,380. Right. You would have gotten a much larger number had you selected a permutation, but that would be wrong. Okay. So, so just know that the larger number will always be permutations. Okay. So 2,380. Combination, 17 items. Oh, I typed a little too many digits there, didn't I? 2380. Arranging 6 books on a shelf. Is that a permutation or a combination?
Permutation.
Yeah, it's permutation. So it's permutation of how many books do we have? 6 books?
6.
Taking
6.
taking 6 at a time. All right, that's just 6 factorial because the formula is like this, right? So 6 factorial over 0 factorial is just 6 factorial because 0 factorial is 1. Okay, so the permutation, you can put that on your calculator too. 6 math prob
720.
here. Good. Whoop. 6. Oh, 720 ways. Great. Shall we do the last one together? You want to go over a little bit? It's 9:50. I don't mind. I'll stay to do the last one if you like.
Okay.
And if you have to leave because you have another class, totally understand. So this is 53, and we have 33 members of the board of directors of a certain nonprofit institution. If they must elect 4 people, a chairperson, first vice chairperson, a second vice, and a secretary, how many different ballots of candidates are possible? Okay, so we have N is 33 and R is 4. That we know. So A is, question, is it a permutation or a combination for A? Oh, and we already got it, Catherine, did you?
Yeah.
Okay, so I like the fact that A is larger than B because you intuitively knew this was a permutation, right? Because of the roles that we are, because the assignments, okay, that we're giving each of these 4 people. So there's going to be a lot of ways we could take those 4 people and arrange them into those roles in the company. So this is definitely permutation of 33 items taken 4 at a time. And then B says if they must form an ethics subcommittee of 4 members, how many different subcommittees are possible? So this is not permutation, but combination of 33 members of the board taken 4 at a time. And this is because this is a committee, a group, or whatever, and order doesn't really matter the way we select them. Order doesn't matter, okay? But here, the roles and assignments here for permutation, the order matters, okay? And that's kind of the clue as to whether or not we use that permutation combination, all right? And then the rest is history. You put that in a calculator. All right, so I'll just stick around for questions. What do you have for me? I'm happy to stay a little longer for you all if you want to go over anything. I do want you to know that when you are taking the exam, it's important for you to access the tools. Under course tools, go to document sharing and make sure you get that formula packet. We're right here at the top, and you can have that out on your desktop or printed. Just make sure you've got that. And the formulas you need to know are for chapter 3 and 4. Okay, you could get it larger. You could actually keep it on your desktop while you take your exam. That is really nice to have, okay? And we know that we have a program to get the mean deviation. And we would just have to square the standard deviation, right, to get the variance. Is there a question? Oh, you're welcome, Zara. You have a great weekend too.